Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Hello everyone and welcome to Development Productivity in a Post-Serverless World. I want to start with the story. So you might be wondering, why am I showing you a slide with a scooter or a moped, as they call it in the UK, and what apparently looks like a computer or a server? So this is a story of 20 years ago when I was working for a telecommunication company back home in Naples, and what we were doing in that company was we were providing authentication for some of the biggest broadband provider in the area. So we did not have the infrastructure to actually run and provide the broadband ourselves, but those kind of broadband provider, they would offload authentication to us, so they will when somebody would try to connect to the internet from their home via their router, a request will come to us to say, should I authenticate this user, should I authorize this user to actually go over the internet or to access the internet or not. And then we know, based on accounts and other information that we had, we would either authorize or deny the request. Now, all of these was handled by a server called Argo. So actually, Argo was a server that we had we have had for some time. It was actually living in our office. It was connected to the internet. Argo was actually living in a room where there was air condition on to make sure it didn't get too hot. And Argo looked very much like the computer you can see here on the slide. And everyone knew Argo. He has been with us for like a few years. We would regularly look after him. We would regularly patch Argo. And we relied on Argo to be there, to do his job of authorizing or denying requests to allow people to go over the internet. Now, one day, what happened was that there was a power cut into the area, and therefore we could not. Once we had a backup generator, to give power to Argo, we could not keep Argo alive for a long time. And actually, we did not have another Argo, so Argo was the only server that we had to handle the job. We could not recreate a new Argo in a reasonable amount of time. We did not know what was on Argo. Argo was a few years old, and during that time it was patched, it was reconfigured, updates were applied. So we didn't really know what was going on. We did not have either the hardware or the knowledge to recreate a new Argo in time. So what did I do? I unplugged Argo. I took Argo on my scooter with me, and I did drive in the traffic of Naples as quickly, as fast as I could, to take Argo to my house. Actually, it was my parents' house at the time, in my bedroom. So I arrived in my bedroom. I plugged Argo back in. I connected it to the internet. I phoned up our broadband provider partners. I gave them the IP address of my house so they could redirect requests back to Argo, and job done. We were back. We were back in business. Actually, Argo was very noisy. He had a very big fan to kind of keep it cool. So one night I couldn't really sleep, with the noise that Argo was making. So I unplugged it again and I moved it in my living room. And so my IP was changed, and that kind of caused a little bit of downtime in service. But there you go. Why am I telling you this? in a post-serverless talk. I'm telling you this because there was a time in which servers were not ephemeral. They were very important. They were long-lived, and entire businesses were actually built and would rely on physical servers, to actually keep going. So my name is Domenico. I'm a principal engineer at Economics. Recently, we kind of rebranded ourselves, and now we called Hardle. So those are some of the things that I do, and some of the things that I really can't do. So I've been in the industry for more than 20 years. I still cannot write a simple regular expression. So what I want to talk to you about today is two things. One, I want to talk about how did we get from servers like Argo to running functions into the cloud. So what was the journey like to move from physical servers to AWS Lambda and Azure Function and all of that kind of good stuff. And also I want to talk about a little bit about infrastructure as code and what kind of role I think that's going to play into the future. So let's start from servers to serverless. So initially, back in the days, we had physical servers like Argo. I mean, they were much better looking than Argo. So they were like flat and they could fit in a rack space. And then those were living kind of data center, and then you had traditionally you had the developers, kind of software engineers on one side, and then you had kind of the operational engineers on the other side, and kind of the worlds between these two was very different. Kind of the tools that they were using, the day-to-day activities that they would perform were very different. Developers, they would write the code, they had little to no idea what was going on into the production environment. They would hand over, the code sometimes in the form of a package to kind of operation, which would then go ahead and deploy the software onto the server. And the operation, they were looking after patching and maintaining not just the configuration of the servers, but also kind of procuring the hardware, issue replacement parts, and that kind of stuff. And so the distance between the two worlds was very big, like significantly, two different jobs with two different kind of skill sets that you will need. Then virtualization came in, and this is where I guess the distance between the two words started to reduce a little bit, because here you'd have things like starting to do some scripting and potentially some configuration as code over those machines. I mean, there was still like a physical hardware potentially owned and run by operation, and the servers here are still long lived. But I guess even in terms of tooling, it will start to kind of reduce the distance between the two teams, because you might both operation and development might start to do some bashing or some scripting, and developers started to get a little bit more information and knowledge around what kind of the virtual machine looked like, and potentially they would also do some of the configuration on those machines themselves to actually run their own software. And so like I said, the distance kind of shrink down a little bit. And then Docker came in, and I think this was like the most significant shift in terms of reducing the distance between development and operation, because here is where kind of the environment in which on which the software runs becomes ephemeral. We don't talk anymore in terms of servers, and we don't give those servers names. They're not long lived anymore, but we talk about in terms of processes and maybe amount of memory I need to run my application and number of CPUs. But we also change the way that we write code, and we stop relying on servers being long lived and configuration being applied up front. And this is also where I guess in terms of tooling and ecosystem brought those two worlds together, because now developers can deploy their own application much more easily. tooling is kind of shared. For example, in the kind of Kubernetes world, if you use that as an orchestrator, you might tend to use kind of Helm as a tool, shared between operational and development. Even if you think about activities like scaling, for example, developers started to take ownership around some of those, because now it's a much easier thing to do in terms of the tooling and in the ecosystem. And so the distance between the kind of activity, the tooling, the skills, I guess between those two words significantly reduced at this time with the advent of Docker. And then after that, serverless came in, specifically function as a service. So the idea that you write some code, you push that code into a cloud environment, and that code magically runs for you. And this had, I guess, an impact in terms of reducing the distance between the two words. But I guess in absolute terms, in absolute values, it was not, in my opinion, as impactful as the advent of Docker. And whilst here we don't have server to manage, and we now talk about business logic rather than processes, and we talk about events that triggers those functions. The distance between the two words, I think, is still there, even in function as a service. And why do I think there is still distance there? It's because for once, for example, the kind of tooling and languages that we use for the infrastructure to run serverless and write the serverless function, the business logic itself, is still different. So for example, here you can see on the right hand side, we have an example of an AWS Lambda function written with TypeScript. And on the left hand side, you see kind of this YAML configuration file, which is used to provide kind of the serverless ecosystem on which that Lambda functions run. Now, this particular example is using the serverless framework as a packaging tool for a Lambda-based application. But you can see that there is still the notion of infrastructure versus application, and the way that we define the two is still using two different languages. So we still need to have to understand the YAML, we still need to understand what's behind it, and we still need to understand TypeScript, and that is still two different I guess tooling. Now the question for me is, what's coming next? What have we reached kind of the plateau in terms of reducing that distance and therefore maximizing the productivity and the speed in which we can write application, or is there anything else? And if so, what is the next thing that is going to reduce the distance between the two words even further, is going to allow us to actually be even faster and at creating systems and application? Okay, and with that, so let's move on a little bit on that and try to explore what might be coming next, and talking about infrastructure as code and what kind of role it might play. So actually, I think that there's not going to be infrastructure as code anymore, or at least infrastructure as code is not going to exist in the same sense that on the same way that it exists today. Because I think going forward, we're going to move to a world where we think more and more about systems as a whole, over differentiating infrastructure and application. And so what we code, it's going to be the system, as in something that produces value to the business and solves a problem, rather than thinking about this is the application and this is the infrastructure on which the application run. The two things are kind of going to be merged together. So actually, the real thing I want to talk about is in our agenda is forget about infrastructure as code and talk about, I think, two emerging patterns that I see more and more when talking to people and companies implementing, which I think is going to play a bigger role into the future. I mean, of course, that's my bet. I might be wrong, but this is where I would kind of put my money on. And one is platform as code, and the other one is infrastructure as code. Now, I think the best way to talk about those patterns is to actually see some code and write and code something and write something. And for that, I'm going to use some specific tools and libraries. Just a little bit of a disclaimer here. I have no a commercial relationship whatsoever with the tools I'm going to show you. I'm not trying to sell you anything. I just think that those two tools I'm going to show you are a good example of an implementation of those patterns, but you can achieve the same things, with I'm sure with many different other tools. Okay, so the first tool we're going to be the first pattern we're going to be talking about is platform as code. And with platform as code, I guess the idea for me is that there are three main characteristics, I guess, that those type of systems would have. The first one is that the language that you use to code your system essentially is the same. You code the platform um, over thinking about either the infrastructure or the application, and you do that by using a single language. So there is no YAML or TypeScript anymore. There is only one thing. And also is that from a deployment perspective, this is kind of an atomic system. It's the deployment unit, and you deploy the system as a whole in a single CI/CD pipeline. So you no longer deploy the infrastructure and then you deploy the application on top of that. So with these three characteristics in mind, let's see how these look, I guess, concretely. And for that, we're gonna be using a Pulumi as a tool that I think is a good implementation of this pattern, and particularly the meta programming aspect of Pulumi. So whilst you can use Pulumi to just create the infrastructure like you will do with Terraform or CDK or CloudFormation, Pulumi has some interesting, I guess, meta programming characteristics which allow us to kind of meet the three or have the three characteristics that I'm outlining here on the slide. Okay, so let's move to write some code then. Okay, so what we have here is, as you can see, is an empty kind of application. So what I'm going to do, I'm going to create a application in Pulumi. We're going to say Pulumi new TypeScript. So what is this going to do? This is actually, okay, we need to make this empty. So what this is actually gonna do? Uh, Okay, so we're gonna create a new application with Pulumi. So Pulumi new TypeScript. I'm just instructing Pulumi. Let's create a new TypeScript application. Let's give it a project name. I'm gonna call test conf42. And let's run this. Okay, we got a dev name for the stack. And okay, now it's installing a bunch of dependencies, a bunch of npm packages. So I'm using TypeScript here because that's kind of one of the language I'm used to. But of course, Pulumi, supports a bunch of different languages. So this was now created. So if we do Pulumi up, this is going now to create an application. So you can see he's asking me, I'm going to get a new stack. Do you want to create the application or not? I'm going to say yes. And now this is happening, in my own kind of account, right? So I still own kind of the cloud infrastructure under which this will run. So let's so you can see this now is an empty application. Like I have a single index.ts file, which is kind of standard for kind of TypeScript or node-based application in general. And yeah, this is empty at the moment, so there's nothing in this application. So let's try to put something. Okay, so I'm just gonna copy and paste this code. Now what I'm creating here is a simple, I guess, HTTP REST API on with the root on /hello, which is going to return some JSON. So you can see here I'm not defining any API gateway or any infrastructure as such. If you're familiar with Express as a framework, for example, this looks like very much like Express, and I'm using one single file, one single language, to create my application. Now, I think before we can actually run this, I need to install the npm package that I'm using here. So Pulumi Cloud, um, and let's try to run it. Now, if we do Pulumi up, so this now will try to create the application for me. So let's give this a second. I'm going to perform this update. I'm going to say yes. I'm going to say yes. Uh, okay. Okay, so you can see that he did not manage to update this because he's asking for the cloud provider, and this is because I own this infrastructure. So I need to tell Pulumi on which cloud provider I want this application to be created. So I'm gonna be doing that by saying the cloud provider I want to use is AWS. Okay, and then because of that, I also need to install the AWS npm package. And I'm gonna need to also tell in which region I want to run the application. So I need to give it some configuration about my AWS environment. So I'm using EU West 1, and now I should be able to actually deploy the application. So you can see that this is now telling me it's going to create a number of AWS specific resources like API gateway and REST API and permission and stages. So Pulumi is inferring what kind of the infrastructure should be um, based on the application I want to create. But if you look at this is like a single file. It's a single it's a single language. I haven't specified any infrastructure myself. I didn't talk about Lambda at all. I'm just saying this is my code for the application. So I am given a URL where the application is running. So let's have a look at that. So let me share this so you can see. Okay, so if I do /hello here, you can see my hello world. So my application was deployed. Okay, let's see something more that we can actually do. So here, so another thing, for example, that we could do would be to actually maybe define a queue. So if I want something to actually happen, asynchronously, so you can see here I can define a queue, and here I'm being explicit about, there is like an AWS queue and what the queue is. But then, I can say when there is an event on this queue, I want to run some code. And like this console log is it's my code here. And again, this is usually like, for example, a callback function, which, as a TypeScript or JavaScript developer, you might be very familiar with. But also the thing that I can do here, I can share code between you. I can say, I have a constant of a variable, and this is a constant of dummy, and this has some value. And actually, you can go ahead and use this dummy value, everywhere. You can use it in here, or you can use it in here. As you can see, it's one application, one file, I guess one thing. So I can actually go ahead and then run this, say volume up, and now, behind the scene, this is going to create for me an SQS queue, and I'm assuming a lambda function with the trigger on that SQS queue. But you can see I've done all of this, using one single language, no Terraform, no YAML, no CDK. My entire application is in one file. So what I coded is the platform, the system, rather than the infrastructure on one hand and then the application on the other hand. And I'm using construct and paradigms that, as a developer, I'm very familiar with. Um, and this is just I guess an abstraction layer on top of the application, because all of this is still running in my own AWS environment. And you can see there is some knowledge about infrastructure, because here you are defining a queue explicitly. Okay. So hopefully you would have seen how, something like the metaprogramming language of Plumi could help writing, an application like this, and thinking about the platform rather than infrastructure and application. I guess the next pattern I want to talk about is infrastructure from code. And I guess it's an evolution on top of platform as code that we just discussed. And the idea is that we're gonna have application-driven system. So all we think about is the application. So we forget about, the cloud, or the infrastructure that we even need to run the application. And that infrastructure just becomes a sub resource of the application. It gets inferred from the application. So it's the application is created first, and then the infrastructure becomes a side effect of that application. And the idea here would be that the system that I build, it's decoupled from any cloud provider. Like I write some code and I run this code somewhere. I don't own anymore, I guess, the cloud provider on which this code is running. Okay, so let's use a tool to show this, and the tool I wanna use to show you this is Serverless Cloud. So Serverless Cloud is a new offering from the same company that runs the serverless framework, and I think again it's just for me a good implementation of the infrastructure from code pattern that I wanna show you. So let's see. We start again from an empty directory. So I got some code snippets to run. Okay, so the first thing we're gonna do, we're actually going to create a new application. Called Cloud is kind of a little CLI to kind of manage serverless cloud application. I'm gonna say create a new one. I want to create a new application in TypeScript. So yes, I want to create a new one. I confirm I want to use TypeScript. I give it a name. It's a little bigger, so let's call it Cloud Conf42. Okay, now this is installing a bunch of things. Um, so you can see already the kind of a structure emerged here with again with an index.js kind of file. Again, very similar to what we've done before. And one of the things that is interesting here, if you read this, is like it's connecting to my personal sandbox. So I'm already without doing anything, without configuring any AWS or Azure environment, I was given a URL in which my application is running. So they are hosting the infrastructure for the infrastructure for me. So let's try to write some code. So maybe what we can do is I'm gonna get rid of all of these and I'm gonna have like a very simple hello world. So you can see this is very much like express like kind of structure when I just give it a URL and then define my API, and this is what I'm gonna monitor. So the interesting thing is that the moment I save this gets updated in my kind of remote cloud test environment. So if I open up this URL, maybe let's open up the browser as well here so you can see. If I open up this URL um, and I do /hello, so you can see I don't know if you can see this, but I have my hello world here responded. And again, no cloud configuration whatsoever. I just defined the API and that they're running this for me. So let's look at some more interesting things that maybe we can do. So as you can see here, you get like the primitive. So you get like an API. You can deal with some data. You can do some scheduling, and you can have some kind of environmental parameters as well. And those kind of primitives are the ones on top of which I can build. I can build essentially my application. So maybe let's look at some data one. Um, so I'm just gonna copy those kind of two API here where you can, you have an endpoint here to store the data and want to get the data. So you can see that I can use the primitive data here to kind of, store some data, and then I'm gonna get some. I'm gonna get some data. So the moment I save this, again, look how fast this is. This is already kind of uh, synced with my cloud environment. So if we're going to open this one up again, so let's look at the browser, and I do, so we have get data, store data. So if I do get data, see, this is returning nothing because I haven't stored the data yet. And then if I do store data, the value is stored, and then if I do get data again, I get the value back. So again, you can see that here, I'm dealing already with data. I haven't defined any database myself. I don't even know what the database is. I'm assuming it's DynamoDB running in AWS, but I have no idea, and nor I care at this stage, because this is all run, for me, behind the scene. I mean, the other interesting thing that we can look at is scheduling, for example. The other primitive that we have available here is scheduling. So you can see I can schedule something to happen, every minute. And if I save this will be deployed, and you will also get direct logging in your console, in your terminal here. And so this is, I guess, also solves, I guess, some of the problem, with serverless around the local development story, which it's not, I guess, the best in terms of tooling and ecosystem. But of course, you can do, I guess, more complex things like, with the data. So for example, one of the other things that we can look at is here, this would allow you to do queries, for example. So if you look at something like an API like this as a users, where you can get the data from the user, and here we're getting all of the users, but here you could write queries. So the this does give you ability to actually operate with, I guess, a little bit more complex data structure. And you can see here I'm getting also the logs for the scheduler function I've created before, and all I had to do is just to save it, and everything is running behind the scene. And again, this is a step forward on what we talked about before. No, it's still single language. It's all TypeScript or all or C# or Go, whatever language you want to go for. But I only care about those primitives. I don't even know now what kind of infrastructure or cloud environment this is running. This is running on. I guess a more interesting thing that you can do here, this is kind of my now local development environment which is running to the cloud, but I can actually create a copy of that environment by sharing it with someone. I can type this kind of share command here, and what this is doing behind the scene is creating a new copy of the environment, and it will give me a new URL, and I can share that URL with a team member or a QA. And the interesting idea here is that as part of that new environment that is getting created, it also contains the data. So whatever data I've created so far, and I think I've created one entry with the kind of store data, that data will be there. And in fact, if I'm gonna open now this new URL which I was given, let me show you the browser, and I do on this new URL slash get data. You see, I already is the value in, because also the data was actually copied over. And of course, I guess from here I can then do deployment, so I can actually do deploy to prod. And now that I am deploying in prod, actually, one thing that we're gonna see is that data will not be synced, right? Because when you deploy in an actual environment, you only want to have the actual code or application deployed, but not the data itself. Now, because the prod environment does not exist for this application, again, behind the scene, this is also creating the environment for me. It will give me a new URL, and that's now kind of the production URL. And then any change I will be doing on my local environment here, it will not affect production. That's still my local environment. Okay, cool. Yeah, so hopefully you might have seen, that how something like this, I guess, can help us implementing the infrastructure from code pattern, where we do a step forward and really think about, the application as the main thing that we code, rather than the infrastructure or that runs it. And in this case, with this particular tool, we also offloading, I guess, the run of the infrastructure to somebody else. That is everything I had for you for today. So if you have any questions, or you are interested in understanding more about some of the patterns that we discussed today, please drop me an email or follow me on Twitter at @mimozzo, and I'm happy to engage in conversation about those topics. Thank you very much, and you have a good rest of your day.